In this video, the second one on the kinematics equations for constant acceleration, I am going to do a couple of sample problems so that you can see the process for using them. Here are the 5 equations that we derived in the last video. Each one involves 4 of the quantities and eliminates the 5th. So we pick our formula based on what information we have and what we need to know. So here's my first problem. A ball is rolling up a hill and has an initial velocity of 4.7 meters per second. 1 second later, it is 2.3 meters further up the hill. And the question is then asking, what is the ball's velocity at this point in time? So the first thing I have to do in solving one of these problems is decide which direction I would like to define as positive. This is arbitrary. It just depends on what the question is, and in this case, I'm going to pick up the hill as my positive direction. So I'm going to draw myself a little picture on the side just to remind me. I could have just as easily picked down the hill as positive and it wouldn't make a difference. Then I'm going to write out the information that I know using my direction convention for the signs. So my initial velocity is plus 4.7 meters per second because it's going uphill. The time involved is 1 second. That one doesn't need a sign because time is scalar. And my displacement is plus 2.3 meters. There's a couple of situations that could be happening here. One is that the ball is rolling uphill and is still rolling uphill. There's one option. The second option is that the ball could be rolling uphill, have reached some maximum, and then started on its way back down again. And we don't know which is going to be the case here. The next thing I do is I list the piece of information that I am trying to find because that helps me decide which formula to use. So I know VI, T, and D, and I am looking for VF. I know nothing about A, so I need to pick the kinematics formula that does not have A in it. So in this case, I need that second one. So I write out my formula. D equals VF plus VI over 2 times T. You have a couple of options here. Either you can plug numbers in right away and solve for VF with numbers in place, or you can do the algebra on the formula itself. I like to do that second option because I tend to make fewer mistakes with letters, with algebra, than I do with arithmetic and numbers. So I am going to solve for VF. Before I put any numbers in, you might choose to do it the other way, and that is fine as well. Once I have solved my formula, I'm going to put in the information that I know from the problem, being very conscious of the signs of these quantities. These are all positive, so it doesn't matter too much there, but some of them could be negative in a different problem. 2 times 2.3 over 1.0 minus 4.7. And when I put that into my calculator, I get an answer of negative 0.1. Now there are 3 things I need to do to complete this answer. The first one is that I need to check for Sig Figs to make sure that I've rounded off correctly. In this problem, all of my given information has 2 Sig Figs, so I need to write my answer with 2 Sig Figs, so I'm going to need to add a 0 onto the end of it. The second thing I need to do is consider units. Since this is a velocity, I know my units are meters per second. And the last thing I need to do is write this with a meaningful direction. Instead of saying positive or negative, what is it in the context of this problem? We defined uphill as positive, so what this negative sign means is that the ball is in this second situation where it is starting to come back down the hill. So my answer is 0.1 meters per second down the hill. Part B says, what is the acceleration of the ball? So I'm going to write out my quantities that I know. I'm going to keep the same direction convention so that I'm being consistent in how I interpret my information. This is actually a case where I know all 4 of the other quantities. I have my answer from part A, which I can also use. So it doesn't really matter which formula I use from this chart, as long as it has A in it, because that's what I need to find. I know all 4 other quantities, so it doesn't make a difference which one I choose. So I'm going to pick an easy one, where there are no squareds and nothing to solve for, where I might have to do 2 steps. Vf minus Vi equals AT. So T equals Vf minus, A equals Vf minus Vi over T. Now I need to be careful of my signs. Vf is negative 0.10. Subtract positive 4.7 over a time of 1 second. So this is going to give me an answer of negative 4.8 meters per second squared. I check my Sig Figs. My calculator answer has 2. My given information has 2. I've already put my unit on, and then I write the answer in meaningful terms of direction. 4.8 meters per second squared down the hill. Finally, part C. What is the ball's position after 6 seconds? I list my given information. Vi is 4.7 meters per second. T now is 6 seconds. I need to use one of my answers from the previous part of the question. I cannot use my Vf number from part A because that was after only 1 second, whereas the acceleration will not change. And I'm trying to solve for D. So I have Vi, T, and A. I'm looking for D. I know nothing about Vf, so I need to pick the formula that does not involve Vf, which is this one. D equals VIT plus 1/2 AT squared. It's already solved for D, so I don't need to do any algebra to rearrange it. 4.7 times 6.0 plus 1/2 negative 4.8 times 6.0 squared. When I put this into my calculator, I get an answer of negative 58.2. I check it for significant figures. I need to round it off to 2. I add a unit, and I take that negative sign and turn it into a meaningful direction. 58 meters further downhill. Now, since this is a displacement, it's important to remember that it's not about how far it went. I never actually calculated how far uphill did it go given its starting conditions. What I know is that this ball started at some position. It rolled up the hill to some maximum. It turned around And this was our part A of the problem, had us about here, and continued all the way down. Here's part C of the problem. And what we've just calculated is this displacement. Here's my starting position, here's my final position, and we've found that. We have no information about the route up the hill and then returning to its initial starting position. To summarize the steps I'm using to solve these problems, I'm reading my situation and defining a positive direction that makes sense given the context. I'm listing the given information using my sign convention I've just decided, as well as the information I'm seeking. I've chosen which formula I need. I've done algebra to solve for the quantity I'm seeking. I've plugged in numbers and I've gotten a decimal answer from my calculator. And then I've done the 3 things to finalize my answer, which is check for Sig Figs, add units, and state it in terms of a meaningful direction. Thanks for listening.